solutions.
We're recording.
Okay, we're recording. This is what we're doing. Oh, this takes a while. Okay, so here's what I'm passing out, and then we're going to not look at it for a minute. This is the lab we're going to do. I'll do it mostly as a demonstration because it won't be any different than doing it 6 times anyway. And these are solubility rules. You want to put them into your notebook because we're going to use them sometimes. This is how you know if a chemical reaction is going to take place when you mix 2 things together. Now, probably module 4 or 5, remember we mixed potassium iodide and lead nitrate together and it turned that bright yellow and we got a precipitate? So this is kind of the same thing. We're going to mix 2 clear, fully dissolved solutions together and we may or may not see a precipitate. Like these solubility rules are how you figure out if you're going to see a chemical reaction before you actually do it. Because if you mix an aqueous solution of an ionic compound with another aqueous solution of an ionic compound, all of their ions are just going to be kicking around in solution together. But if there are 2 ions that can now meet each other because one came from one solution and one came from the other solution that are not that soluble in water, bam, they're going to form a precipitate. And then you actually have a chemical reaction. If you mix 2 aqueous solutions together and all the combinations you could make out of their ions are still soluble, you will not have a chemical reaction because they'll all just stay in solution happily together. So these rules make the difference. So what you will do is we'll write some balanced equations here, and then we'll analyze the products, right? So if I mix calcium nitrate and sodium hydroxide, then I would get, if they traded, I would get calcium hydroxide and sodium nitrate. So then I'd look up my 2 products, right? I'd say, okay, sodium nitrate. Well, rule 3 here says all salts containing these anions are soluble. Nitrate. Okay, all salts that are nitrates are soluble. So sodium nitrate, soluble. Good. Calcium hydroxide. Strong acids and strong bases are soluble. So here's a list of strong bases. Calcium hydroxide is not on my list. So we move on. Insoluble compounds, rule 7. All hydroxides are insoluble except alkali metals. Row 1A, barium and strontium. Calcium hydroxide is slightly soluble. So, calcium hydroxide. It depends on the concentration if it's going to stay dissolved or not. So then we'll just have to observe. But if we see a precipitate, we can bet it's not going to be the sodium nitrate, which is totally soluble. It's going to be the calcium hydroxide, which is only slightly soluble. So then we just have to put our phases in. If we see a reaction, we're going to label sodium nitrate as aqueous and calcium hydroxide as solid, and that is the precipitate. If we don't observe a precipitate and we have 2 things that are soluble, then there's no reaction. So predicting when reactions occur. And it'll get easier as you get some practice, but you'll need this list, this abridged list of rules because the full list goes on forever. And you'll want to keep that because we'll use it again occasionally when we need to figure out if we're going to have a reaction. All right, so quick review questions. We'll start over here with Micah. When you dissolve a salt into water, which compound is the solute and which is the solvent?
Okay. Yep.
Jenny, point camera, got it.
So I said solvent to solute, and water was the solvent.
Okay, salt is the solute, water is the solvent. Perfect. Aaron, contrast the way ionic compounds dissolve in water and the way polar covalents dissolve in water. Feel free to use this.
With ionic compounds, it separates into ions and then dissolves, and then in polar covalent compounds, the molecule doesn't separate into ions, but the molecules separate into the.
Okay, so they just get surrounded. They don't unbond. Here they get surrounded and they literally separate into 2 pieces. So that's a key point that's different. Okay. Number 3. Oh, and on the test, if you can't get into words that these ionize and get surrounded and these just get surrounded, where the oppositely charged end of the solvent surrounds the oppositely charged end. If that's hard, a drawing will do the job, if that's easier for you to communicate. Liam 3 says, what is a saturated solution?
Well, the solution that can't dissolve in or solute.
Right. And what can affect the concentration of a saturated solution?
Heat and pressure.
Temperature and pressure, perfect. Austin, what kind of solute, solid, liquid, or gas dissolves best under high temperature?
Solid.
Solid. And Kristen, what kind of solute dissolves best under high pressure?
Gas.
Gas. Grace, what kind of solute has solubility that's least affected by conditions?
Liquid.
Liquid. Jenny, if a solid solute is, are you pointing at yourself?
No.
If a solid solute is not dissolving well in water, what should you do?
You should heat it up.
Heat it up. And heating, remember, both increases solubility and rate. If you want to go faster, what else can you do just to affect rate?
For solids,
For solids.
you could crush it.
Crush it and
Stir
look at your
it.
classmates. Stir it, yes. They're all stirring. This is really practical for your life. You can get more sugar in your tea by crushing and stirring.
Thanks, guys.
And 8. Jolene, if a chemist makes a solution in a beaker using water and a solute that dissolves endothermically, would the beaker feel hot or cold?
Cold.
Cold. Okay, so on to solve for practice problem. What do we only have 2?
Yeah.
2, awesome. Okay, so hot tubs generally contain water at a temperature of 38 Celsius. In order to keep the water clean, solid solutes are dissolved, and hot tub manufacturers warn that if water gets cold, it will get cloudy. Why does that happen?
Because it changes the concentration, or just doesn't
So
dissolve quite as well.
Exactly. When water gets cold, the concentration of a saturated solution does what? Increase or decrease?
Decreases.
Decreases. So then that cloudiness is caused by what? You're not part of the solution.
Precipitate.
A precipitate. So you've got precipitate and probably just being kicked around instead of falling to the bottom because the hot tub is flowing. And Lily, if you have an open glass of, I won't even say the word soda pop, that just kills me. Sitting on the counter, it gets flatter than the same open glass sitting in the fridge. Why?
Because the glass that's in the refrigerator hasn't been opened yet, and so the air pressure is higher inside the.
Okay, well, it does say open, but if you had higher pressure, that would be good. High pressure keeps gas dissolved, and that's totally true.
So the coldness affects the solubility. I forget what it does. It decreases the solubility, doesn't it? Or no, more temperature increases it. So
Right.
the colder the soda pop, the higher the solubility.
Yes, gases are more soluble in cold liquid. And you guys know if I stuck, and I have one I might do next week, if I got some hot water and I took a test tube of soda and I set it in the hot water, it would look as if it were boiling, but it wouldn't be boiling, it would just have its gas coming out of solution. So, lab, and I did not email you guys the solutions for the extra 10, module 10 problems. I will do that really, so you can check your work on those this week. I'm not sure I even have an answer key. I'll email you, Jenny, to make sure. Well, I'll decide if she got them right.
Thanks.
And if you find any problems with the answer key, let me know, because, I make mistakes. It could happen. So we're going to do the lab, and then we're going to talk about that extra problem I emailed you. That's the next thing.
Mrs. Dawes, do you want my test?
Oh, yes. I'll come around and collect tests if you guys lay them out. And
Under a lab report.
if you have lab reports, I'll take those. If you don't, please email them to me. Because, I'll have extra ample amounts of spare time while vacationing in Key West to grade your lab reports on the beach. And
Who's gonna do the best?
I'm so excited, sorry. But start writing the two products that you could form if you switch the ions on that lab sheet while I collect stuff. Oh, I'm supposed to go over lab reports. Well, I'll just make comments.
Okay, I emailed you my preference. Did
Yes.
you want like a hard copy of
Did I send it back?
I don't think I ever got it back.
Okay.
I
Here.
can check, but if you wanna take that.
I
it's-
think I sent you
Okay.
comments.
So what do you want us to do, this right here?
Yes.
Okay, there was like a general email that went out to everyone. I didn't fix those things, like some of the things I need to add. and
Okay.
Some of the things I already had, so.
Okay.
That's the email I add for my discussions.
That's fine. Yes, if you hand wrote them, you may end up having to copy it over if it has a lot of changes, but if not, you can add. Yes. Oh, I don't want to take away your stuff. No.
Can I mail
That's yours.
first? Can you
Yes.
email your address and then I can mail my test to you?
Yes.
Okay.
Your mom definitely has my email address because I definitely communicate more with my physical science students. So. Okay. I don't want to miss that.
I know, she's just like,
I don't know if we're there yet. I think she just wants to
So take a few minutes to write a
we have this little time after deadline.
Yeah, you should finish whatever you haven't done in Module 11 for the class that happens 2 weeks from today.
What do we do
I was
this week?
talking
Will
about
these,
for this.
this
Yes,
in according
so-
to this?
Let's do the first one together just to make sure. So this is called, you guys learned about, 3 or 4 kinds of chemical reaction. Acid-base reactions that almost always form a salt and water unless you've got a truly covalent thing. Then you get 2 ions. You learned about combustion reactions, you learned about formation reactions, and you learned about decomposition reactions. This is a new kind of reaction called a double replacement reaction, which is generally really easy. So that first one is, what do we have?
Calcium nitrate.
Okay, calcium nitrate. So
Calcium
then I have to think how to write it. Well, calcium's a 2+, nitrate is a 1-, so it'd be like that. And that's aqueous. And the phases are important in double replacement, so you need to put them. Or leave space for them if you don't know them yet. And then sodium hydroxide.
Yeah.
Okay, so double replacement reactions are easy. You just take the cation from one and give it the anion from the other, and then write it correctly. So calcium is a 2+, hydroxide is a 1-, so calcium hydroxide. And then the cation from the other, the anion from the other, sodium nitrate. Both are 1 charges, so, right. So, then don't worry about phases yet, we'll just write them all down, and then we'll consult the solubility rules to see if, yes, it's a chemical reaction or no. I'll start cutting these up, and then we'll test them out and see if our predictions are good. I'll change color. I didn't write on the sheet, but all of the reactants are aqueous solutions.
Alright, I'm gonna like pause this because that's got to be the most boring video ever.